I lead AI products at Rocket Learning. We focus on early childhood education, so solving for learning outcomes for 3 to 6 year old kids. I'll just quickly get to what we built. The problem we saw was, so we work with around 3 million kids in Anganwadis in India. So I'm not sure if you know, but Anganwadis are government preschools, and we have 15 lakh Anganwadis in India. And traditionally, Anganwadis have been focusing on nutrition, right? And like the Anganwadi workers that you have, these are like about 15 lakh Anganwadi workers. They are not trained to educate kids, which is now changing. So you see that there is a massive gap. 70% of kids in low-income countries cannot read a letter or letter or number in grade 3. So it's a big problem. So to solve for that, we built this GenAI-powered learning tutor. I'll just show you a demo. Hopefully the demo works. I'll just show a video.
Learning kids, get ready now, because learning is going to be even more fun. Hello friends, your very own friend, Apu, is here. Are you ready to learn by talking with Apu? Click on the WhatsApp link to start talking with Apu. Then, hand over the phone to your child and give them the chance to listen carefully, think on their own, and respond. Come, let's see how you can talk with Apu.
So just for context, so this is a web application. It's teaching a 4-year-old child how to recognize beginning sounds for Hindi letters. And how it works is there's this mascot, which is an elephant, and it is having a conversation with the child. So the idea is that you are teaching the child through lifelike conversations and interactive play. And if you see, it's multimodal. If the live demo was working, I would have shown it to you on a bigger screen. You see, it's multimodal. So there's an image that's coming here. Child is speaking, and the mascot is sort of guiding the child through it. I'll show you the video.
दूसरा शब्द सुनिए, मकड़ी, मकड़ी, आप भी बोलिए। माशा मकड़ी। शानदार, आप बहुत तेजी से सीख रहे हैं।
So kids, are you ready? I'm coming to you very soon. Listen, speak and learn with Apu.
So as you saw, basically here, the Apu is trying to teach beginning sound to the kids, and it's very conversational. If by the time demo starts working, I'll try to show that as well. But today I'll quickly talk about how we built it. So we took this rapid prototyping approach where we did like a lot of field visits, and we did a lot of qualitative and quantitative testing rapidly. And I'll talk about why rapid prototyping is important, how we did it, and what were the sort of outcomes we were able to drive. So firstly, I am from Delhi, I live in Bangalore, we work out of an AC office, right? And we are building for these 3 to 6-year-old kids in like Chandauli in Uttar Pradesh. It's like a village, you know, where there is abject poverty. And half the times even I am not able to understand the accent in which people are speaking there, right? So there is a massive disconnect when we are building products. So in my experience, I've seen that we spend a lot of time to build the perfect product, but at the end, it's not very usable because it was not built taking the context of the end user in mind. So there is a massive disconnect. So to solve for that, what we tried to do was we had an initial hypothesis, and based on that, we tried to come up with like a quick prototype. And we had, so let's make it interactive. When you think of an AI tutor for a child, like what do you imagine? Any thoughts? Okay. What else? Okay. So in terms of the interface, when you're thinking of the interface, right, the child, like the AI tutor, is supposed to teach the child, let's say counting. There can be so many possibilities on how the interface could be, right? It could be a chat interface, it could be voice-based. Sorry? Chatbot. But even when you think of a chatbot, there are so many ways to imagine it, right? It could be a Siri type of interface. Uh, it could be like Alexa, right? There could be a physical device. There could be a mascot. Exactly. It could actually be a human being, right? Hmm. Yes, even then, right, like you say you want a character, like who's to say a animated character is more effective than a like an actual human teacher, because you can also create a human avatar. So there are so many design decisions that need to be taken, right? What should be the tone of the avatar, right? And so on and so forth. So um our approach was to sort of follow design thinking, where the first step is we try to empathize with the end user. We did a lot of field visits, did user interviews to try to put ourselves in their shoes, right? And look at the world from their lens and define the problem very clearly. The problem here is that we have teachers, right? But the problem is that there is a lot of disparity. So if you go to a class in a government school, you will see that it's a 50 kids class. One kid is, let's say, at addition, which is grade level. So they're supposed to be learning addition. But there are 5 other kids that are still struggling with counting. And that's a massive problem. There's a lot of disparity. So it's a big problem for the teacher. How do you design the curriculum in a way that you basically take everyone along? And our research showed that it's not really possible to do it effectively in a big classroom, which is why personalized learning is super critical. And I think sort of all of us agree with that. So that's a problem. How do you drive personalized learning through an AI chatbot? And then we built a prototype. So we sort of stitched along a prototype in 50 days. And we did a series of field visits. I'll quickly talk about what were our hypotheses in the field visits and sort of what were the insights. So the in the first field visit, our base hypothesis was like, our kids even like, so we created a Figma prototype and like a very simple prototype, and we wanted to understand whether they even find it engaging. Because getting a 4-year-old child to focus on anything is a task. I'm sure like some of us are, there would be some parents in the audience, like how hard is it to get like a 4-year-old child to focus on anything, right? Let alone some app that's trying to teach you something, you know? So first thing was like whatever prototype we have, like do they even find it engaging, right? Do parents find it useful? Because at the end, like kids could find it engaging, but if parents don't find it useful, like they would not really let the child engage with the phone, because at this 3 to 6 year old age, parent is a facilitator, right? And is the experience intuitive? And we tried multiple approaches, right? We voice, like even in voice, like we tried multiple different approaches. So so when we tried this, the first problem we faced was context. So there was, so in like the same similar interface I showed you, we asked the child, we showed the child a picture of a house. And we asked the child, makaan kis shabd se shuru hota hai? So answer is ma in Hindi. But the child said ghar. Now our bot was trained to mark ma se makaan, but it marked the whole thing as incorrect. Now that's like the bot is wrong because the child gave a correct answer. We asked the child, what is this object? What does it start from? Child said it correctly, that this is a ghar. But we marked it as incorrect. So that was a big problem because we were not really taking context into consideration. Second was response time. Our latency was like 15 seconds when we started because there is speech-to-text API, there's the NLM, there's a text-to-speech API, there's a whole stack. And third was, like we were trying, again, in an AC office in Bangalore, I'm doing experiments, I'm talking with the bot. But when I'm testing in a classroom, everyone is screaming. Like it's very hard to get like 4-year kids to like be silent, right? Especially when 20 of them are together. So noisy environment was a big challenge. So I'll show you a video from the first field visit. This is an actual child using it. Can you please switch on audio for this?
वाले शब्द सीखें म आवाज वाले शब्द सीखेंगे क्या आप तैयार हो हाँ दीद गई मैं तो खेलती हूँ सही कहा मम्मी मछली और मटका ये सब आवाज से शुरू होते
So I think the video answered the question. Like, do kids find it engaging? Yes, we saw they find it engaging. So much so that she almost jumped off her seat, right? If you understand Hindi, she said, "Main jeet gayi," which means I won, right? And she would just not like leave the phone. Like I was there when we were doing the testing, and she just wanted to play with it again and again. No, this is not one-to-one. If you see she's surrounded with kids. No, the conversation is only happening one-to-one, but there are multiple kids. But one interesting thing was we did not expect kids to be smart enough to know then when one child is speaking, they're supposed to be silent. We did not have to tell them that you're supposed to be silent. Like, most of them were smart enough to know that if, this person is engaging, like we should just, be silent. Yeah, so first field visit's core hypothesis was validated, but we found a bunch of problems around asset contextualization, noisy environment, and so on and so forth. So we fixed all of that, brought down the latency to about 4 seconds, and then went for another field visit like a month later. And there we saw another problem. So first problem was factual errors. What it means is that you were seeing that there's some image coming on the screen, and the mascot is asking a question to the child, right? So let's say it shows 3 apples and asks the child how many apples are there. And the child says 4. Now it's an incorrect answer. But what the bot was doing was it was still marking it as correct. And vice versa. Let's say there were 3 apples and the child says 3 apples. The bot was marking it as incorrect, which is like a major blunder. Like you can't have a bot teaching a 4-year-old child making factual errors because this is foundational learning. So this was one thing that we figured out was like it was breaking. And second major problem was sorry, I didn't get your point, sir. Mm-hmm. Yes, yes. That was so. Most of the kids that we experimented with, they did not face that problem. They were able to comprehend. But I do agree, if there's like a vision problem, that could be a roadblock. So something to think about. Yeah, yeah. That I have not, like we have not really thought about solving, but that's a good point. Yeah. Second thing was kids are not sure when to speak. So like the bot starts speaking, right? And now they ask a question, like they were not really sure when to speak or when to take a pause, and when to listen. So that was a big problem. So I'll just talk about how we went about solving these problems. Yeah. In the first problem, we figured out what was happening is, so we have this big prompt. You don't have to read into it. What was happening is, like, if you have been experimenting with LLMs, you would have seen that there is something called chain of reasoning, right? So what was happening is that actually found out like whatever model we were using like wasn't really doing well on basic maths. Even like saying like 3 apples, right? It was like breaking in a bunch of places. So what we did was we basically added a reasoning section in the prompt. So I'll try to like zoom in, but yeah. So what it is doing is like we are giving a chain of reasoning that, whenever the bot is asking, like the child is saying something and you're asking a question, this is how you need to think, right, stepwise. So we gave this reasoning framework, and we then tested again, but we saw like it was a little bit better, but it did not really move the needle. So then we started doing research, and we figured out that there is this problem called lost in the middle when you do prompt engineering, So what happens is that, like, what essentially we're trying to, what is happening in the prompt is we are giving it a bunch of instructions to follow, right? Let's say there are 100 instructions that we have asked the, like, specified in the prompt. But what ends up happening is, like, the LLM doesn't have perfect accuracy, like, in terms of following instructions. And, like, it follows the instructions that are at the top of the prompt and at the bottom of prompt much more accurately, which is very unintuitive, right? Like, you can't really know that something like this would happen unless you run an experiment. So through our research found out there's something called lost in the middle problem. So what we did was, we did nothing. So we just took this piece of prompt, which is this reasoning section, moved it from center to the end, and then did another experiment. And we found out that accuracy increased by like 30%. It matters a lot. Yeah, so there's this thing called retrieval accuracy. So if you're giving X number of instructions in the prompt, then the retrieval accuracy for each of those instructions differs based on the placement. So this is, it is reading line by line, sir. So basically, there's a context window. I can explain it to you one-on-one. But it reads like tokens sequentially, right? That's the whole base architecture of the model. So what we found out, we did nothing. We just moved this section of the prompt from center to the end. And we saw that, like, the accuracy jumped up by 30%, right? So again, if it were not for rapid experimentation, we probably would not have found out about this. Second problem I pointed out, kids did not know when to speak, when to take a pause. How we solved it is that, I'm sure all of you use Google Pay, Bheem, right? You see that, like, every time you make a transaction, there's a ting sound. Does anyone know why that is there? Or any other guesses? Why is there this ting sound? Sorry? Confirmation, right? Like, no, they don't really have to go to their messages and check if the transaction has come. If there is a sound, they know that the customer has made the transaction. So we used the same concept and applied it here. So what we did was, every time, I'll show it to you. Again, can I get voice on the video, please? Okay, there's no access. Sorry, this is not my laptop. But you got the idea. So what happens is, like, every time Appu says something, it'll just say ting, right? Appu ends speaking, it will say ting, and the child has to speak. And once the child ends speaking, then there's another ting. So that is speech to text. So we do a lot of work on how to reduce noise using our post-processing, sir. No, so models are smart enough to figure out what is noise and what is what the user is saying. Yeah. So, and another thing we did was, in the onboarding, what we did was that every time a new user onboards, we explain to them that when I have a mic in my hand, I am speaking and you are supposed to listen. When there is this line at the bottom, there's this waveform, then you are supposed to speak. And when there is a cloud on my head, I am thinking, so please wait. It is done in the vernacular language. So this is to explain the child, before they engage with the bot, we take them through this flow, and we see that it's very effective. Then they know that when there is a cloud, you're supposed to, I'm thinking, you're supposed to take a pause. When, there's this red line coming, then you can speak. And when I have a mic in my hand, you're supposed to listen. Okay. Yeah. So then we did our beta launch, where we just tested on 500 users. And you see, so this is a funnel. We saw that, like, let's say about 140 users landed on the session, but only 78 out of them started the session. Like 45% people dropped even before clicking on the play button. Any guesses why that could be the case? Why were, let's say, 45% users dropping off even before, like, clicking on the play button? Okay, other guesses? What in the user experience you want to take a guess? Because you saw the demo, so it's just like a play button that comes. Okay, any other guesses? Okay. There are no words. It's just a visual this thing. And there's like a big play button. Yeah. Okay, I'll explain. So what we saw was that they were not able to give microphone permission. So like most of them were not able to give the microphone permission. And like if you see, this is coming in English, right? Like so what happens in Google Chrome or any browser is that the language is by default English. And like almost none of our users know how to read English, right? So there's this pop-up that comes, it's in English. They have no idea what it says, right? So they just like cancel and drop off. Even parents don't know, sir, how to speak English. Most parents, at least in, most of our work is in the north, so they don't really understand, like, know how to read English. Yeah, they don't know what a microphone is, like, what is really happening here. They have no idea, right? So they just see this pop up and they drop off. So we try to do like an interesting thing. So you see this GIF on the side, right? So what happens is like if they basically click on never allow or they, let's say, click somewhere else in the pop-up blocks, we just launch this GIF. And this GIF is just telling you that like you click on this button. They don't really know what's happening. Yeah, it's guiding them there to click there. And we saw that this works. That, like if we show them this is what you're supposed to do, and we give them a video on WhatsApp that, you are supposed to do all this, click here. So just these two things, like a WhatsApp nudge and this GIF, I'll show you how it was able to improve. Just a minute. So it was able to improve by like almost 30%. Like another thing, like just one last thing, is that how do you really track? So we have like about 3 million users, and even the beta is live for about 100,000 users. How do you even track what are the quality of conversations? What are kids really saying? What are parents really saying? And what we found is that we designed this portal where you can track every conversation that's happening in real time. And not only can you track it, you can even play the audios. If it were my laptop, I would have played it for you. But you can actually listen to every conversation that's happening. Yeah. So it's all anonymized data, but it's saved. So you can actually track all the conversations in real time. And you can see, and like when we started playing these conversations, we found like super interesting things. So a lot of times what was happening was, like, let's say the bot asks how many apples are there, and the parent is saying 3 apples, and then child is saying after parent. Yeah, it stores on like, no, sir, it's on the cloud. So store it on the cloud. There's nothing happen on device. Yeah, so this is the last slide. So basically, the point I'm trying to drive is that what we learned, especially when you're designing users that operate in a very different context than yourself, then I think 80% of the time should be spent on testing and tuning, and 20% on building. Yeah, that's me. Thank you.